performance, load, or reliability related. Now, keep in mind this was probably 6 or 7 years ago. So that number is, that's a bigger number now than it was then because of inflation and also because of the euro appreciation too. So you'd have to think in terms of say Australia dollars. We're talking easily 200,000 Australia dollars at this moment in time. Now, some of you might remember the Victoria's Secret 1999 Internet holiday lingerie show. I hesitate to bring up such a moldy oldie, as the saying goes, but this is actually really a true classic of failure to manage performance, load, and reliability risks. So Victoria's Secret had this show online of runway models showing off lingerie, and great concept, great idea. It was such a great idea, everybody wanted to come and see it, and so the load would go up and up and up, and instead of politely declining to accept additional connections, it would simply try to make a connection, and there obviously hadn't been enough performance, load, and reliability testing. So load would go up, system would crash, system would come back up, they'd start it again, the load would go up, the system would crash, and there was a yo-yoing thing that went on for a number of days before they got that worked out. This is not the way to earn a reputation of being tech savvy. You look like a dolt, really, and these kind of things happen corporately. And finally, the new emergency phone system introduced in the UK in one particular region had some reliability problems, among other problems, and these resulted actually in fatalities because the ambulances would get sent to the wrong place, or the ambulances wouldn't get dispatched at all until 5 minutes later or 10 minutes later when the system came back up, and the ambulances weren't showing up on time, and people were waiting for ambulances. It's not like a matter of inconvenience like when the taxi doesn't show up on time. All right, so I think the risks here are clear, and while, again, I can hardly go through and talk about every possible thing that you need to worry about in performance, load, and reliability testing, I'm going to focus on 5 lessons that I've learned in the years of doing this. I started doing various forms of performance, load, and reliability testing in 1987, so it's something that I've got some experience with. And learned a number of lessons. I'm going to try to illustrate those lessons using case studies, because I think case studies are helpful to put this in the context of an actual project, and try to give you some tips and some warnings. And without further ado, let's look at what those 5 lessons are. So, realistic test environments. Realistic in the sense of resembling production. That's the first lesson. Many organizations get tripped up on this. Realistic loads and transactions, things that look like real-world scenarios. That's another not infrequent source of mistakes, that the loads don't look like anything the system's going to face in the real world. Testing the tests with models and simulations, and testing the models and simulations with tests. It's a complicated thing, performance, load, and reliability testing. You want to have confidence in your results, and it's not trivial to do, but it is. There are some techniques here that I'll discuss that can really take you a long way from unsure to being very sure. The use of the right tools, not necessarily an endless quantity of tools, but the right tools, the ones that you really need. And then getting started early and not waiting until the end. It's the last of the 5 lessons that I'm going to talk about. And I just want to mention again, these are lessons earned in blood, either mine or somebody else's. But if they were earned in somebody else's blood, I was there to see it. This is personal experience on projects that where things went well, and also standing watching people make mistakes in these areas and having stuff blow up in their face. So, this is the kind of thing that I think, as the saying goes, wise man, any man can learn from his own mistakes, but a wise man can learn from others. I think it's old American aphorism that would apply here. That hopefully you can go away from this presentation today taking these lessons to heart without having to experience them the hard way. Okay, so let's start with lesson number 1. The need for realistic environments. Now, something that I have talked about a number of times and continue to need to bring up because it's pernicious seems like the wrong word, but it's a recurring problem. The real world, inappropriate real world metaphors that slip into our thinking when we're doing software testing, and just software engineering in general. Now, so examples of that. If you're building a bridge or you're building an airplane, one of the things that you're going to do is you're going to build a scale model. And when I say scale, I say that the thing is completely accurate in its proportions, but its size is 1/10 or 1/20th or whatever, 1/50th of the real thing. And that affects some of its properties, but other properties are preserved across that scaling, at least to some point. So you can build a scale model of an airplane and put it in a wind tunnel, and what you observe happening in airflows over that wing will be something that can be extrapolated to what's going to happen on the full-size wing. Now, there might be some differences, but those differences are determined by mathematical formulas. We don't really have that in software engineering. Software does not exist in the physical world, and so things like Bernoulli's law and the tensile strength of steel and all of that kind of stuff, the engineering materials and the way the real world interacts with other objects in the real world, none of that stuff applies in software. Software is a world made up by us for the most part. There are a few small counterexamples of that, as I mentioned, things like binary trees and normalized relational databases, where there is some work that's been done, theoretical work that's been proven out in practice. You can say, okay, this is performance characteristics of this, that, or the other thing. But for the most part, we're just making it up. And so it's very difficult to extrapolate because there are these unforeseen constraints that then give rise to unforeseeable non-linearities in performance or load or reliability degradation. And I'll show an example of that a little bit later in this presentation. And it's really quite striking. So we had, here's a first example here. We had a client that created network security software, and I don't want to get into a big long explanation of how it worked, but basically it was a centralized server that would pull in information out of various computers on a network, and old and new types of computers. They had a lot of legacy support as well as support for new systems.